Okie dokie, number 4. They ask us to use the intermediate value theorem. They say one application is that it gives rise to a root finding algorithm via bisection of intervals. Let f of x equal this. Show that f of x has a root in 1 to 2. So what we're going to do is find f of 1 and f of 2. Note that this is not an ordered pair. It's an interval. It's an interval of x values from 1 to 2. So we're going to plug in 1, we're going to plug in 2, and we'll talk about what happens next. So 1 to the 5th power is just 1 minus 5 times 1, 5 plus 2. That would be 3 minus 5, so negative 2. F of 2 would be, I think, 32 minus 10 plus 2. That would be 24, I think. Regardless, the idea is that f of 1 produces a negative value, f of 2 is a positive value. So what that means is, as long as f of x is continuous, which it is because it's a polynomial, that means that if at 1 it has a negative value of negative 2, and at 2 it has a positive value of 24, and the function is continuous between those 2 points, it's got to hit 0. It's got to have one root at some point on that interval. Okay? So that's how we showed it. Let's see. In which of the intervals, 1 to 3 over 2 or 3 over 2 to 2, must f of x have a root? How do you know? Well, you could repeat that process, or you could like plug in 3 over 2 to the function. That might help. Maybe let's do that. Let's do 3 over 2. We're going to use Desmos. So 1.5 is 3 over 2. So 1.5 to the, not 2, but 5th minus, was it 5 times 1.5 plus 2? Yeah. So plugging in 3 halves, we get 2.09. So roughly 2. So f of 3 over 2 was about 2. So what does this mean? Well, if it was a negative 2 at 1, and at 1.5 or 3 halves it was a positive 2, that means that it's crossed before 3 over 2. So that root lies in between 1 and 3 halves. And we know that because it goes from negative to positive just between 1 and 3 halves. And between 3 halves and 2, all the y values are positive. So that's how we know. They say iterate this procedure to find an interval of length 1/16 in which f of x is guaranteed to have a root. Wow, so we have to split 1 and 1, so 1 to 3 halves into more halves, basically. So we have 1, 1.5. What's halfway between those? That'd be 1.25. So let's start there, I guess. We have to plug in 1.25 is the idea. So we're going to plug in 1.25. 1.25 to the 5th minus 5 times 1.25 and then plus 2. So we get a negative. So what does this mean? So let's do x values and y values. It's going to look real whack, but 1.25 we got a negative, okay? And we already knew that 1 we had a negative value as well. So this means that since at 1.5 we had a positive, that means that the 0 occurs somewhere between 1.25 and 1.5. So that would be between 5/4 and 1.5, or sorry, 3 halves if I'm staying consistent. So then halfway between those would be what? What's halfway between 1.25 and 1.5? That'd be 1.375. So let's plug that in. 1.375 to the 5th minus 5 times 1.375 plus 2. And we get a positive. It's very small, but it's a positive number. So what does this mean? It was negative at 1.25. It was positive at 1.375, which means the root is somewhere between those. And I think that's as far as we need to go because it's a length 1/16. I think that's right? Because this, no, that's 1/4. We did that already, actually. Wait, no. That's 1/4. So that was only 1/8. Oh gosh, that was 1/8. All right, so we got 10/8 to, what would that have been? 11/8. So 11/8 that. 11/8 is, yeah, okay. Whew. All right, let's split it in half one more time. So what's between 10/8 and 11/8? Maybe it's easier to do fractions because let's multiply everything by 2. We get 20/16 and 22/16, right? So it'd be 21/16. That's all there is to it. 21/16 is the next number. 21/16 to the 5th minus 5 times 21/16 plus 2. And we get a negative value. So what does that mean? So it's very clunky. I'm very sorry for this. Probably could have done this a lot cleaner, but at 21/16, there's 20/16, 21/16, and 22/16. Just to translate here, this was, let's make sure I get this right, 1.375 was 22/16, and then I think 1.25 was this one, the 20/16, and so this was 21/16. All right, so at 1.25 we had a negative. We just found that 21/16 is also negative, and 22/16 was positive, I believe. Yeah, so this means the root lies between 21/16 and 22/16. And that is the interval of length 1/16 in which f is guaranteed to have a root. Once again, because it crosses from a negative number, or it is f at 21/16 is negative, and f at 22/16 is positive. So since f is continuous between these two x values, that's how we know f has a root between these two x values. As long as I did my calculations correct, that's the idea.